everyone. Today we're going to determine the area of a regular polygon. There are three parts for this topic. I will put the link of the other two parts in the description box below. This is the first part. So we're given a regular polygon here and we're supposed to determine the area for this. So we're given a line that is connected from the center to the edge of, or to the one of the vertices of the a regular polygon, and the length of that is 12 units. So what are the steps that we need to do in order that we can find the area of this polygon? So first step, we determine the sum of the interior angle of a polygon using the formula 180 times n minus 2 and label this value in the figure. So there is another video that talks about how to determine the sum of the interior angle of a polygon, and I'm going to put that over here. So this is the formula. So pretty much like the formula is just up there. So we have this in a different video. So using this formula that we have here, so I can go ahead and write the sum of the interior angle of this polygon is equal to 180 times n minus 2. So we need to determine what the n is. N refers to the number of sides, so then we can go ahead and count it. 1, 2, 3, 4, 5, 6, 7, 8. So the n is 8. So this is an octagon. So from here we can go ahead and put in the n value to that. So that is 180 times 8 minus 2 is 6. And so if we multiply 180 by 6, that would be 1080. So 1080 is the sum of all the measures of the interior angle. So the sum of each one of these. So by the way, please remember that in a regular polygon, all of these angles here are congruent, so they are equiangular, so all the angles are equal. So this would be 1080. To find the measures for each of this angle, so each angle would be, so I'm gonna show the work here. So each angle, each interior angle is equal to 1080, so that's 1080 divided by 8, which is equal to 135 degrees. So the sum of each of these is 135. So this is 135 degrees, 135. So I'm just gonna label this measures right here, 135. So this is 135 degrees. So this is 135 and this is 135. So each one of them is 135. So if you add all of the 135 here, 8 of them, that would be 1080. Next step, again, our task is to determine the area of this polygon. So our next task is to divide the polygon into triangles and label all the measures. So from here, I can go ahead and divide it into parts. So I'm just gonna draw some triangles here. So I'm gonna draw the triangles to on this polygon. So let me do that, and then we draw the rest of the parts as well. So right here, so that this is actually the second step. So we already divided it into triangles, and we are going to label the parts. Now, here's the thing that we need to remember. Since the whole thing is 135, so each of these is 135, and we got that from the first step. We were able to determine the measures of this angle. Just a reminder, this 135 is divided into 2. So this whole thing is 135, but then since I actually divided into little triangles, so this one triangle right here is actually half of 135, which is 67.5. That's 67.5. This is 67.5. And the same thing for the rest of the parts. So this is 67.5, 67.5. So that the total of these two is 135. So pretty much it's half of 135. So that is 67.5. Now I am going to take one of these triangles. So just imagine this polygon as a pizza. It's an octagonal pizza. So if I take one piece of this pizza, I'm gonna put that over here so that we can, because if we have a triangle, it would be easier to determine its area. So then we have here, so I took one of the piece, so I will make it really big. So that's one piece right here. I took this piece out from there. So this I will label this as green. So this green piece that we have here had been taken out, and I put that green part over here and make it big so that we can see what's going on. So the measures for this green triangle would be, this is 67.5. So this is 67.5. And this is 67.5. Now, if I drop a height or an altitude or a line connecting from the vertex right there down, so if I drop a line like that, it will form a right angle. And the measure of the side here was 12. So what I would want to do now is I will take just half of this triangle. I need to determine what is the area of this half of this triangle. So I've drawn that over here. So the measure of this angle, so I'm taking half of it, then I will put that up here. So this is 12, and then this is 67.5. And again, we are supposed to find the area. The area for a triangle, the formula that we have here is base times height divided by 2. So if we label the parts here, this side is our base. This side right here is the base. So this side is the base. And this side is the height. So that's the base and height, and we don't know what it is, but we are given an angle 67.5, and then the hypotenuse was 12. So we can go ahead and label this part. This is our opposite to 65. So I can label this as the opposite to 67.5. The base is the adjacent to 67.5, and then the 12 is our hypotenuse. Okay, so then we can solve for the height from here. Since the height is the opposite and we have the hypotenuse, so we're going to use the SOHCAHTOA. So opposite and hypotenuse would be a so. So then I can go ahead and set it up. That is sine 67.5. That is opposite. The opposite is the height over the hypotenuse is 12. So that is height over 12. And then from here, I can go ahead and we remember that this one has an invisible denominator of 1. So then I can cross multiply these two. So let's cross multiply these two right here, and then the 1 and the height. So then 1 and height is actually just equal to height. So our height is actually 12 times sine of 67.5. And then if we use the calculator on this, just a reminder for the calculator, be sure that the calculator is set in degrees. So our height is equal to, multiply these two together, that would be 11.09. So this is our height. And we are going to use the cosine to find for the base, because the base is adjacent and we have the hypotenuse. We can use tangent if you want, that should be fine too, but we can set up cosine of 67.5 is equal to, the adjacent is the base over the hypotenuse is 12. So that's base over 12. Remember, this is over 1. So I put that over 1 right there. And then we are going to cross multiply these two together. So that is the cosine of 67.5 and then the base. So then this would come out, base is equal to, that is 12 times cosine of 67.5. So then again, be sure that your calculator is set up in degrees. So if you multiply 12 and cosine 67.5 would be 4.59. This is our base. Now, we are supposed to find for the area of just this triangle right here. So to find the area for this triangle, we already have the height and the base. So then we go ahead and plug it in. So our base is 4.59. Our height is 11.09 divided by 2. So then if we multiply these two together and then divide it by 2, the answer is 25.45. So this has been rounded off. So this is the area for this one piece of triangle right here. This one right here would be 25. So this is 25.45. Now, how many of these do we have? So we're supposed to use this equation that we have here. So in order that we can find the total area, that would be the area that we got from step 4, which is 25.45 times n. N means the number of sides. So how many sides there are? 1, 2, 3, 4, 5, 6, 7, 8. And then others are going to ask, like, why do we multiply that by 2? Because each of the piece here will have 2 of these. Remember, the one that we solved here is just half of the piece of this whole thing. So that means each of the sides here will have 2. So once we have the sides, multiply it by 2 because each side will have 2 of this 25.45. So multiply this by 2 so that the final area, so the total area for this would be 407.22 units. So this is the total area for this case of the polygon. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!